Hello, I think my screen is visible to everyone. Welcome to today's live session on NPTEL course Environmental Chemistry. And this is 11th week live session. I am Saptarshi Bose here, a PMRF research scholar from IIT Madras. So I will go for the first question. Today's topic is more related to redox reaction and their applications in our environmental chemistry or the wastewater or water treatment. So the first question is, uh, in a hop reaction involving nitrate and ammonium, if the PE is 8 and pH is given, that is 7, and the ratio of nitrate and ammonia comes out to be x multiplied by 10 to the power 10 to the power 19, not minus 19, 10 to the power 19. So what is x? And first you have to do the balance equation. You have to write down the balance hop reaction, and then you can go for the solution. So I hope you have gone through the lectures, videos, and also the material. So it will be easier for you if you refer that. So balancing the half reaction is easy for everyone because these things you are doing from your 8th standard or 7th standard in chemistry. So just do that and then try to answer this using your. Okay, let me check whether any issue. Hello, are you still facing any audio issue? Hello, hello. Is it okay better now? Please let me know if there is any issue. Can you hear me now? Please check your internet connection. Maybe that is due to the internet connection. If it is breaking, then please let me know. So I think now it is audible for you. Okay, we'll go for the solution. I'll not wait much today because it's already late. So the first answer will be the question of the first. The answer will be 5.25 to 6.25. It will be in the range of this 5.25 to 6.25 depending upon your calculation. So how we will solve this? First you have to, just a minute, you have to write down the equation. Just yeah, first you have to write down the balanced equation. First you have to write down the half equation, half balanced equation. Then you just need to do the summation. If you do the summation, you will get the whole picture, the full equation, right? So this is our full equation, right? Nitrate, and we are adding 10H plus, then 8 electrons, then we are getting ammonia and water. So if this is the equation, so I think all of you are familiar with this equation also, right? So P equals to P naught, that is nothing but log 1 by K, and then I'm getting this NH. NH is this coefficient 10, and then N, how much electron is present, the coefficient of the electrons, that is 8, and this is pH. So minus log of H plus concentration. Then I am going for 1 by n, right? So let me save the writing tool. Okay. So you can see that there is 1 by n. This n is coming from this electron, the coefficient of the electron. Then log, this is the reduced form, right? After reduction, we are getting this, and this is the oxidized form. So reduced form divided by the oxidized form, we are getting this equation. So this equation has been already explained in the lecture session how we are getting this equation. So this is nothing but the reduced form, and this is nothing but this reduced form, this is oxidized form. So our equation is going in this direction. Oxidized form is getting reduced, right? So just put the value here. So P was given as 8, right? And PE naught you can find out from the standard value of K. If you go any standard book or NIST database, you will find this K value. From that K value, we can calculate for what is the K value for this equation, and from the K value, you can calculate the PE naught, because this is standardized form. This will not change, right? So no need to worry about this. And yes, so you are getting this PE naught from your standardized table. Then comes the 7 multiplied by 10. 10 is the coefficient, and then divide by 8. 8 is this electron. Then 1 by 8 I am getting, and then log NH4 plus by NO3 minus, right? And then just you have to solve this numerically. If you solve this numerically, you will get the value as 19.76. And if you just want to remove this log, then you will find that 5.75 into 10 to the power minus 19. So this is our answer, 5.75. I hope this is clear for everyone. So I'll go to the next question. This is among these following redox couples of the common metals. You can see that PE naught values are given with the couples, and which of the couple contains the most potent oxidant and which is the most potent reductant. This is again a conceptual question, no need to calculate anything numerically. Just based upon the concept of PE naught, you can answer. Okay, we'll go for the solution. So the answer will be A, that is the first one, Pb4 plus Pb2 plus, and then Al3 plus Al. So we'll know the reason. The higher the Pe naught value, more potent it is oxidant, right? And if the low P value is lower, then it will be a potent reductant. So if it is having the P naught value in the higher side, then what will happen? It is already in the reduced form. It can now oxidize, right? And in the same way, if the P naught value is lower, then it is in the oxidized form. It can get it is a proton reducted, right? So we'll go to the next question. That is in some module. I'm not sure whether this is 52 or not, but it's okay. Just go through the question. Like we talk about the analogy between pH and PE graphs. So match the followings. You just have to match using your concept. Already some hints are given in the form of this base plus H plus. I'm getting acid, and in the same way A oxygen plus it's getting the electrons and it's forming in the reduced form. It's forming the reduced form of the. So you have to match with A, B, C, D, and P, Q, R, S. Okay, we'll go for the uh, just a minute. Okay, I got answer from Loganathan. Okay, so we'll check the for this question. The answer is B. So we'll know the reason. I'll just give you one hint. It's already there. It's already inside the material. Like you just don't need to go deep inside the theory. If you just open the material, if you just play the video, it's there only. So nothing to explain more. Just only one thing I will say that you can remember Heisenberg-Henderson equation. If you just remember how the pKa was related to pH and their two forms, base and acid, then you can already know how to answer this, right? So here the answer is B. And if you go through the connection, then PE naught is related to pKa. In the Hazel's-Huygens equation, pKa, it is related to P naught, E naught. Then A oxidase corresponds to the base. Then A reduced corresponds to the acid, and E plus corresponds to the H plus ions. So pH, pH. So there, that is the negative logarithm of H plus concentration. And similarly, this E minus or electrons can be related to H plus ions. So again, conceptual question, more or less, assuming the following reaction occurs: Mn2 plus H2O, and I'm also adding half oxygen, aqueous oxygen, which is in the dissolved form. Then I'm getting MnO2, solid form, plus H2H plus. So you have to identify which one is the electron donor and which one is the electron acceptor. This is also a very easy question, very easy conceptual question. Okay, we'll go for the solution. No need to wait much for this. So the correct answer is D. We'll know the exact reason. So if you go for Mn2 plus, it denotes the electron as oxygen state change from 2 plus to 4 plus. And here oxygen accepts the electrons as oxygen state change from 0 to -2. So here you can see it was +2. And if you go here, just calculate what is the oxygen state of Mn. What you will find for oxygen 2, -2 multiplied by 2, that is 4, right? So this Mn is having +4. This is -4, -2 multiplied by 2 for oxygen. So Mn will be +4. So from +2, it is going to +4. And what about this oxygen? Oxygen was 0. Now it is going to -2. So that is why we are getting these things, right? Uh, we'll go to the next one. So D is the correct answer. Let's go to the next one. Using the half reactions in the standard books, I already told you for the first question, determine the del P oxidation reaction, the ratio for the following oxidation of NH3 aqueous to NO3 minus by reduction of oxygen to H2. So again, you have to write down the half reactions, then form the complete balanced reaction, redox reaction. then go for this equation that was related to PE and P naught, the form, oxidized form or the reduced form. Use the previous equation, which I told in the first question. I'll solve this. Okay, I will go for the solution. So answer will be in between 6.5 to 7.5 depending upon your um, calculation. So this is very easy. First you have to write down the half reactions. Please go through the lectures how to find out the half reactions. So if you just if you can write down the half reactions and if you can balance them, then you can get these two, right? One is 1/4 oxygen plus H plus E minus, then I'm getting half H2 and then 1/8 NH3 and so on. And you will find this log K value, which is nothing but P naught value, right? So this P naught value or log K value is there inside any standardized table, inside your book or inside the NIST database. You will find these two values, or it will be given during your examinations. It possibly the table will be provided for your convenience. So you will get these values, two values from here. And if you just balance this, or sorry, if you just add this up, if you do the summation, you will get that this is a total full equation. And from here, you have to find out which one is getting reduced and which one is getting oxidized. And depending upon this, you can find in here also, you just need to add this up, you will get 7.05. So this is very easy. Just to add this to, and you are getting 7.05. That will be the del PE naught value for O2 by NH3. And this is nothing but log K, right? It is already explained in the lectures how these two are related. So actually we are referring this log K as PE naught, nothing else, right? So again, we will go to the next question, that water at pH 7 exists in equilibrium with a gas containing 21% oxygen and 0.05% ozone, and the following equilibrium exists: O3 plus 2H plus 2 electron, then I'm getting oxygen H2O. So PE naught value is given here, 35.06. Determine PE for the above reaction at the mentioned concentrations. So already P naught value is given, no need to check any table or any database. Just use your equation. This P equals to P naught plus uh, NH by N, pH, and 1 by N, then the log of used an oxidized form, and calculate this. So this is the oxidized form. Always be careful, this is the reduced form, right? Okay, so we can go to the solution. The answer will be B, and this is a very easy question because everything already given. So P equals to P naught minus 1 by NH by N PH, then 1 by N log O2 divided by O3, reduced form and oxidized form. So you just have to put the values. Already P naught value is given 35.06, right? Then how much, what is the coefficient here? 2. So 2 multiplied by the pH was 7 and divided by 2. Why? Because for electron, this the coefficient is 2. So divided by 2 and 1 by 2, it is also coming from the electrons, 2 coefficient, and then log, that is 0.2 divided by 0.005. It's in the percentage form. So there is no need to convert in any other units because that will cancel out each other. So if you just write down the ratio like that, because it's the ratio form, you will find that P equals to 26.75. So this is very easy. So the next one is determine the ratio of total dissolved arsenate to the total dissolved arsenite and arsenate, right? So one is then in the 3 form, one is in the 5 form at pH 6, and PE is given as 5. So you have to determine the ratio of these two. One is 3 form and one is 5 form. One is more reduced form, one is more oxidized form, right? The same thing, same equation, nothing else, everything is given. Okay. So Golf will check the answer, right? So the answer will be A, and yeah. So first you have to write down the equation. That's your job, first job. You have to write down the balanced redox equation. If you can write down the balanced equation, then other things are very easy. So you know what is the P naught value. P naught value was not given, but from the standardized table you will get this. From the value of K you will get the value of K, and from the K you can convert it into P naught. So this is standardized form. We know the P value is given already 5, and then P naught value 2.64. Then we are here, it is used as plus, but actually it was minus. That's why you can see that it's in the reverse order, oxidized form by reduced form. So because we are using here plus 1 by n, you can use negative form also, no issue. Like you just need to change. I think all of you were familiar with the numerical conditions for log, how it behaves, what are the properties. When you are changing the sign, then it will, the denominator can go to the numerator and numerator can come to the denominator. So I hope this basic mathematical fundamental concept is clear for everyone. So that's why I'm not explaining that. You can just play with the signs, right? You can play with this log, denominator and numerator, nothing else. So then m by n, it's written in the form of m. You can use nh, no issue. And multiplied by pH, same. Just put all the values here, and you will get what is the ratio for these two. is same as the first question. In the first question also you have found out the ratio. So depending upon which one you want to find out, want to find out, depending upon that you may have to change the sign, right? You can reverse this. So it was asked as a third form by the fifth form. So we are getting like that plus 3 and 5 form. You can from here also you can calculate, like see here oxygen will give minus 2 into 3. So that is nothing but minus 6. So this AS is in the form of plus 3, right? That's why we are getting total as minus 3. So the charge is minus 3. So minus 6 plus 3, I'm getting minus 3. So this is plus 3 form and this is 5 form, because minus 2 multiplied by 4, that is nothing but minus 8. And the total charge is again minus 3. So it should be plus 5. So then it will be at the end will be minus 3, right? So this is plus 5 form. So from here also you can find this is plus 5 form, this is plus 3 form. We'll go to the next question. The theoretical oxygen demand for Cresol, the equation, the chemical formula is given, and it will decompose into carbon dioxide and water. So you have to find out what is the theoretical oxygen demand. First, you have to write down the balanced equation with Cresol and oxygen, and it is converting into carbon dioxide and water. Then just find out. In milligram, you have to find out. Okay, so the answer will be in between 2.02 to 3.02 depending upon your calculation. So this is our balanced reaction. First job is, every time your first job will be to write down the balance equation. So that is the most important job. If you can write down, then it's okay. So this was Cresol, the chemical formula was given. Then we are adding 8.5 oxygen. I'm getting only carbon dioxide and water. That was the condition. It is totally converting into carbon dioxide and water. That's how it will do the experiment related to the theoretical oxygen demand. If you want to know what is the theoretical oxygen demand, then you have to convert this organic molecules completely in the form of carbon dioxide and water. So that is the fundamental rule. Then what you are doing, this 16 multiplied by 2, 16 the molecular weight multiplied by 2 gram, or you can convert it into, because it's in the form of ratio, right? So it doesn't matter whether it's you are going for gram or mg, so it will cancel out. So if you can write 16 multiplied by 2 multiplied by 8.5, that much oxygen is required for uh, this much uh, gram of or mg of cresol, right? So if you just write down what is the cresol molecular weight, then you will find 7 into 12 plus 8 into 1 for hydrogen plus 16, right? So that's what it's written here. So you can calculate how much it is coming, and this is for the oxygen. So you know what is the unitary method. I already told you in the first session, if I am not wrong, in the first live session. If you just go and check the video, you will find how to do this kind of calculations. Just a simple unitary method of your sixth standard or fifth standard. So for one, for sorry, not one, for of this much mg of cresol, this much mg of cresol, I am using this much mg of oxygen, right? For 1 mg of cresol, how much oxygen I need? So what you will do, this divided by this one. So this is coming from the molecular weight from the oxygen, that much of the oxygen's contribution, and this is from the cresol. For this much I need, for this much I need this much oxygen. Then for 1 mg, how much I will need? Divide this divided by this, and you will find that is 2.5, right? The simple unitary method. Then this is the connected. These are the connected questions for question number 9 and question number 10. A soil sample was analyzed for manganese traces due to recent contaminations from nearby factories. The soil solution contains 10 to the power minus 5 molar total manganese 2 plus and 10 to the power minus 2 molar of CO3 and 4 mg per liter of dissolved oxygen. The pH of the soil was determined at 7.5, and for calculation purpose, we assume that rhodochrosite is the possible solid forming. So you have to find out or determine the solid rhodochrosite, whether it's in the undersaturated form, oversaturated form, or saturated form. Use your vMinTech software. Again, this is a very easy one. Don't be confused with a bigger name. Don't be confused or frightened with this bigger name. Just put the values, whatever, put the data, whatever you have in this vMinTech software, and you will find this in the table. So don't be frightened with this many terms or many forms of manganese. So, okay, we'll go on the solution. We may run out of time. May not wait longer. So the answer will be B, that is oversaturated. Okay. So if you go to the vMinTech software, now everyone is familiar with this. First you have to fix the pH. It was given at 7.5, right? So from this drop down, go fix that 7.5, put the value. From these add components, add your components. For oxygen, it was 1 point, how much it was? For oxygen, 4 mg per liter, right? And you can convert this 4 mg per liter in the molar format, molar format or molar format. So you can change the unit, right? From here, you fix the 1 unit and then convert the oxygen from 4 mg per liter to what will be its molar concentration. And from the drop down, also select other two, that is Mn2 plus and CO3 2 minus. If you just add those, then go to this view and edit list, right? After adding, go to this view and edit list, you will find this Mn2 plus as 10 to the power minus 5, then CO3 2 minus as 10 to the power minus 2, oxygen 1.25 into 10 to the power minus 4. So okay, back to the main menu, this option. Then if you just run the vMintech software, you will get this table, right? You are also familiar with this table. So go to this main output menu. From there, you will find that the saturation indices for the minerals. There will be one option. Three options are there, right, at the bottom. So go to the proper option, click there, you will find this. And here, uh, rhodochrosite is in the red with the red marking. And if you go here, you will find the red text is indicating the oversaturated form. So this is the oversaturated form. It's very easy, right? And then the next question from the vMintech database, you can find that another thing is manganite. Manganite is there. Yeah, this one. So the question is, what is the chemical formula for manganite and the oxidation test? So don't need to go back to the vMintech software. Just concentrate here only. The equation is already given. So you can write down what will be the possible formula and also the oxidation state. So very easy. No need to go for any software. Okay. Yeah, this one is very easy. So go for the solution is the C, and how you will get this C option. C. First of all, we are having two oxygen, right? So it needs to be balanced. So I'm getting two oxygen, two, and one hydrogen here. This manganite is having one hydrogen, and another three hydrogens are here. So totally it was four hydrogens, right? Four hydrogens and one oxygen, right? And one Mn2 plus. So I'm getting one Mn, then two oxygen, then one H, and other three hydrogens are here. So no need to go deep. It's very superficial question. And then all of you are familiar with how to calculate the oxygen state. So minus 2, right? Minus 2 and then minus 1, and I am getting this as plus, it should be 0 totally, right? So it should be 0 totally, and I am, if you just calculate this, I'm getting as 3. So it will be plus 3. So hope you enjoyed this session. Thank you everyone for joining today's session. So we'll meet on the next Saturday. That will be possibly our last live session. Thank you everyone. So you may leave now.